Good morning. So we're working on 5.2 today. We're going to solve a linear system using substitution. So if you haven't done so already, please pause the video and do the minds on for lesson 5.2. Okay, so by the end of today, you're going to be able to solve a linear system using a method called substitution, and it is another algebraic method this time to find the point of intersection of a linear system. So recall that a linear system is just two lines, and right now in 5.1 what you learned to do was to solve a linear system by graphing the two lines and identifying the point of intersection. So let's see how you did with the minds on. So we're going to graph x minus 2y minus 4. So in order to do that, I'm going to rearrange the first one. So that's going to be minus 2y equals minus y plus 4 when I move the x and the minus 4 over. And then, of course, we have to divide through by negative 2 on all terms. And so what I end up with here is y equals 1/2 x minus 2. So don't forget to make sure of your signs, right? Negative over negative, that's a positive. And this is like an invisible 1 here, so this is 1/2. It helps to write the fraction because then we're going to be able to identify the slope, which is 1/2. Oopsie. And the y-intercept, which is negative 2. And then for slope, of course, if we have it in fraction form, rise over run. Okay. The second one then, maybe I'll make it a different color, is already in slope y-intercept form, which is lucky. And so I can identify the slope, negative 3/4, and the y-intercept, negative 2. So let's start with the first one. I'm going to graph the y-intercept of negative 2 right here, and I'm going to apply the slope of 1/2. Up 1, over to the right 2. Got my 2 points. I'm going to, that's not a very good line. I'm going to draw that line again. I'm just going to adjust the slope of that line a bit. That's a little better. Still not great. There. That's better. And I'm going to put some arrows on there. I'm going to draw the other line. The other line has also a y-intercept of negative 2. Oh, how nice. Look at that. I've already identified my point of intersection. I might as well draw the line though. And so this is going to be a slope of negative 3/4, which means I can go down 3. I ran off the page if I go down 3. So instead, why don't I go up 3? 1, 2, 3. And then my negative has to go to the bottom, to the 4. So then I'm going to go left 4. 1, 2, 3, 4. So that works. Gets me over here. So I'm going to draw my line. Just change the color of it. See. Yeah, good enough. And perhaps I will, here, I'll just change the color. Oh, cancel. Properties, and we're going to make it blue. Okay, so I've got my 2 lines. What else do I need on here? Need to identify the point of intersection, so I'll use red for that. That's the point of intersection is 0, negative 2. It happened to be the y-intercepts this time. Let's see, I can put the equation on here, y equals negative 3/4 x minus 2. I can identify another point of point on my blue line, so this is negative 4, 1. And on my black line, I can identify this point here. I went from 0, 0, over 2, down 1. So this is the point 2, and negative 1. Okay. Oh, and I didn't put the equation. Y equals 1/2 x minus 2. So that's this equation here, or I could have used the original equation. It doesn't matter which one. Okay, so it says find the point of intersection of the lines. I should conclude then, therefore, and I'm just going to use POI for point of intersection. You can use that too if you'd like. the point of intersection is 0, -2. Didn't ask me to check, but I could have on my own just substituted the x and the y in to each of those equations, original equations, just to check to see if left side equals right side, but I'm pretty sure it's going to. All right, so we're going to move on to the lesson today. It's a difficult lesson because it's very algebraic, so you may have to pause the video and ask me some questions, and that's perfectly fine. I get that. I'm going to ask you to do your own question, and then I want you to make sure that you actually are trying to do it on your own, because it is a matter of just persevering through a few examples until you get it down pat. Okay, so we're going to solve a linear system using substitution. I'll just go through the steps right now quickly, but they'll make more sense to you when we do an example. So remember, a linear system is 2 equations. So what you want to do in step 1 is rearrange one of the 2 equations so that it is in the form y equals or x equals. Okay? Sometimes they're already presented in that form and you don't have to rearrange them, but if they aren't, then you're going to have to rearrange one of them. And it doesn't have to be just y equals, it can be x equals as well. Okay? Either one. And then what you do once you've got one of them in that form is that you substitute the other side of the equation, the right-hand side of the equation, into the other equation for whatever variable you've got isolated. And then what you'll have is an equation with just x's or just y's in it. So you can solve for that variable, the x or the y. And then once you've solved for the x or the y, you're going to substitute the value of the x or the y into one of the original equations. You're going to solve for the other equation, or the other variable, sorry. So if you had already solved for y, when you sub that back in, you're going to be able to find the value for x. You're going to do a check, and then you're going to write a final statement. Okay, so this is kind of your go-to. If you forget the steps, go back to here and just review the steps. So let's try and do a question. So it doesn't say what to do, but really I might say something like solve. It's simple as that, using substitution. Okay. Remember, solve means find the point of intersection. So I don't want to graph these two to estimate the point of intersection. I want to get the exact answer by using substitution. So the first thing we're going to do is we're going to isolate one of the variables. Well, the good news is that they're both isolated. So I'm going to call this one 1, and I'm going to call this one 2. And what I'm going to do then is I'm going to sub y equals x plus 4 into 2. So what I want to do now is I want to look at the first equation. When I look at the first equation, I see that y is equal to x plus 4. So this side equals this side, right? So if I wanted to, instead of where the y is in equation 2, I could put an equivalent expression in there because y is equal to x plus 4. And remember, when we're solving, what we're looking for is where those y's are the same. So we are solving, we're finding the x value for equal y. So I'm assuming these y's are the same. So I can replace this y with this expression. Okay, so I'm subbing in y equals x plus 4 into 2. All right, so let's do that. So now 2 is going to be y equals 2x minus 2, but where there's a y, I'm going to put x plus 4. So I'll just put a little arrow to show that that's where it's getting substituted into, right? We're going to replace this y with this. So here we go. X plus 4 is equal to 2x minus 2. So I'm just replacing this y with this expression because they're equal to each other. And now you can see that I have an equation with only one variable, x's. So all you do now is you use all the skills that you learned in chapter 4 to rearrange and isolate for x. So I probably should move this x over to this side so that my x's are positive. So if I do that, I'm getting 4 over here equals 2x. This becomes minus x when I move it over here, and then minus 2. And then I need to move this minus 2 over. It becomes plus 2, and then there's a sign of plus in front of the 4. So now I've gotten rid of the 2 on this side. And if you're more comfortable doing the plus 2 business and the minus x here and minus x here, that's fine. Okay, I'm just doing it a sort of a quicker way, but you feel free to use that process in order to isolate the variable. Okay, so now we've got 2x minus x, which of course is just 1x, better known as x, and 2 plus 4 is 6, and look, we've solved for x. So now in the next step, what we want to do is we want to sub x equals 6 into either 1 or 2. So you always go back to the original equation and you sub it in to solve for y. So I'm going to look at the two of them. I think I'll pick the first one just because it's all positives. So I'm going to say y equals x plus 4. I'm going to sub in where there's an x, I'm going to put in the 6. And I'm going to then solve for y. So y is 10. So now I'm just going to say, so x equals 6 and y equals 10 is my possible solution. I think I've got an answer. So 610, remember this is x, this is y. We always do it in x, y order. So 610 is a possible solution. And I say possible because we always want to check. So let's check 610. So what we do to check is we substitute the 6 and the 10 back into our original equations. So again, I'm just going to write down y equals x plus 4. And I'll write down the other equation, y equals 2x minus 2. Okay, so 610, this is the x, this is the y. So 10 here equals 6 plus 4, and remember we don't move anything around, we just work this side through till we get a number. This side is already a number. So yes, left side equals right side. So far so good, but it has to work for both equations in order for it to be the point of intersection, right? It has to be on both lines, so it has to satisfy both equations. So 10 equals 2 times 6 minus 2. Well, this is already 10. This is 12 minus 2. This is 10. And this side's 10. So I've got 10 equals 10. That's great. So now I know that left side equals right side here. And my conclusion is that the point 610 is the solution. Therefore, 610 is the solution to the linear system. Okay. So that's substitution in a nutshell. It's not easy, and we're going to do some more examples, but the tricky part really goes back to up here when we just we generated the equation with only one variable by doing substitution. Okay, that's the tricky part. And if you don't understand that part, you really do need to make sure that you're asking me to give you some more examples or to show you in a different way. Okay, so don't be shy to ask for some more help on that. Okay, so let's look at the next example. So I'm going to get you started here, but you're going to do this on your own. So when we look back, I'll just quickly go back to the steps. It says rearrange one equation in the form y equals or x equals if necessary. So do you have to rearrange one of them, or do we have it in x equals or y equals form already? Well, you can see that we already have it in x equals form already, so we don't need to rearrange it. We'll call this one 1 and this one 2. And what we're going to do then is we're going to sub x equals 4y plus 1 into the other equation, into 1. Oops. Okay, so this part here, this part here is the same as x, right? Because it says x equals this. So everywhere in this equation that there is an x, you're going to replace that x with 4y plus 1. So let me just do that. I'll just write, whoopsie. So now I'm going to write my equation. This time it's 2 times x. So I've got a 2 times this instead of x. So I'm going to put a bracket, and this is 4y plus 1. So that's like my x, right? Right here, this is like my x. So I've got 2x. I still need to write minus 3y equals 12. So ignore the x there. I've got all of this in terms of only one variable, y. Now this is complicated because I have to get y all by itself, and so I still have to do some fancy algebra here by distributing this and rearranging and isolating for y. Why don't you try to do that? Pause the video right now, expand this out, and solve for y. Once you solve for y, go ahead and substitute it back into either 1 or 2 to solve for x, and then check. And then come back and check to see if you've got it right. Okay, so go ahead and pause the video, see if you can get x and y. Okay, so here we go. We're going to distribute that 2 through the bracket. That's going to become 8y plus 2 minus 3y equals 12. And when I combine the 8y and the minus 3y, I get 5y. When I get rid of the 2 on both sides, so that's like minus 2 and minus 2, right? Then I'm going to end up with 12 minus 2, which is 10. 5y equals 10. Divide both sides through by 5. Did you get y equals 2? I hope so. And then the next step is to sub y equals 2 into, remember, either 1 or 2. Which one are we going to pick? We want to solve for x. So if it's in x equals form already, that would be the best choice. So I'm going to pick 2. So x, equals 4y plus 1, and x equals 4 times y, which I know is 2 plus 1. So x is 4 times 2, which is 8, plus 1, and x is 9. So my ordered pair is, remember, it's x then y, so it's 9, and then my y is 2. So 9, 2 is a possible solution, and we are going to check to see if it satisfies both our original equations. So let's do that. Oops, I should probably keep an eye on what the equation was. So we're going to check the point 9, 2. So we'll start with 2x minus 3y equals 12. So we go back to the originals. We don't go back to anything that we rearranged ourselves, because we could have made a mistake, right? So if you check in the original, you can pick up mistakes. Okay, so this is the x, this is the y, remember? I'll just put that on top just to remind us. So we're going to have 2 times 9 minus 3 times 2 equals 12. Let's figure out what this left side is. 18 minus 6 equals 12. Well, 18 minus 6 is 12. Hey, left side equals right side. So far, so good. Let's see about the other one. Our x was 9. Our y was 2. So 4 times 2. So we've got 9 equals, that's 9. That's not 9. What am I saying? It's 8 plus 1. I'm getting ahead of myself. 8 plus 1 is 9. So 9 equals 9. And left side equals right side. So again, we can conclude, therefore, 9, 2 is the solution to the linear system. Okay. Awesome. Oopsie. Okay. So that really is the algebraic method of substitution in a nutshell. There is one more example. So what I'm going to get you to do is to try this one on your own. Again, you're going to start from the beginning on your own this time. Remember, the very first thing you want to do is isolate one of the variables. And just for consistency, I'm going to tell you that when I do it, I'm going to isolate the x in this equation. Okay? So you could try and isolate the y in this equation, but I'm going to ask you to isolate the x in this equation just so that my solution looks like your solution. Okay? So pause the video right now and let's see what we can do. If you need help getting started, please put up your hand and ask me, and I'll come around and give you some help. But do the best you can to try it on your own. Go back to your examples, the first two, and see if you can get this, okay? Good luck. Okay, so I'm going to isolate for x. So let's just name them again, 1 and 2. And I'm going to say x equals, when I move the minus 2y over, it's going to become 2y plus 9. So that's my new number 1, right? We'll call that number 3 because we rearranged it. So now we're going to sub x equals 2y plus 9 into the other equation. So I can't sub it back into this equation. I got to substitute it into 2. So everywhere where there's an x, I'm going to replace it with 2y plus 9. The method is called substitution, right? We're substituting for a variable. So we have an expression for x. It's 2y plus 9. So everywhere in that equation, we're going to write, so 3, and then I'm just going to maybe put it in red here, times 2y plus 9. So that's the 3 times x. Now I'm going to slap in the minus y equals 17. So remember, this is replacing x. So 3x minus y equals 17. That looks like 2. Okay, so now we're going to distribute that 3 through, and we're going to get 6y plus 27 minus y equals 17. Well, can we clean this up? 6y minus y, that's 5y. And then the 27 can get moved to the other side. It becomes minus 27. Let's move this. 5y then is equal to minus 10. And then, of course, dividing through both sides by 5 gives me y equals negative 2. Okay, we are going to sub y equals negative 2 into one of the two equations. So I'm not going to write either 1 or 2. I'm going to pick. Let's see, which one does it make more sense to sub into? 1 or 2? It's hard to tell. I'm just going to pick 1. Sometimes it's not obvious. It doesn't matter, in fact, which one you substitute into. You're going to get the same answer either way, but sometimes algebraically one's easier than the other. All right, so I've got an x minus 2 times my y. Oopsie, maybe what I'll do is just write the equation out first. So number 1 is x minus 2y equals 9. All right, so x minus 2 times my negative 2 for y equals 9. All right, so x minus 2 times minus 2, that's plus 4, equals 9. And x equals 9 minus 4, and x equals 5. So what have I got for my xy? I can say so 5, and y was from up here, negative 2. So 5, negative 2 is a possible solution. But we need to check. Okay, so let's check. So we're checking with the point 5, negative 2. And our first equation, gotta go back up, sorry, was x minus 2y equals 9. Remember, go to the originals. And the other one was 3x minus y equals 17. All right, let's substitute in for the x and the y. This is 5 minus 2 times minus 2 equals 9. Well, does it? 5 minus 2 times minus 2 is plus 4 equals 9. 9 equals 9, and left side equals right side. X minus y equals 17, so 3 times 5 minus 2, that's really tricky, equals 17, right? It's minus y, but y was minus 2, so minus minus. Can't write minus minus without separating them with a bracket. So this ends up being 15 when you multiply this. A minus minus, when you're multiplying two minuses, that's a plus. And we've got 17 over here, and 15 plus 2, of course, is 17. And left side does equal right side. So we can conclude then that the point 5, negative 2, is the solution to the linear system. So, I know that's hard. I know it's not the easiest thing, but if you can get, as I said, sort of this whole part here, kick-starts the process. And if you can get that substitution thing going, the rest is really not that difficult. Okay? So please now, that was the last example. Please do your consolidate and start on your textbook work. I will write that on the note that I've given you. So do your consolidate for 5.2, put it on my desk when you're done. If you're having difficulty, we can go through some more examples, put up your hand and we'll work through some. And then start on your textbook work. And as I said, you've got all weekend to do this. Work on it in class, but you really must do some examples if you want to have any hope of success at mastering substitution. Okay, thanks for listening.